So in this video, we'll be seeing about the glue logic required. Let us say we have some AXI master and an AHB target. So that we need some conversion here, right? So let us say there's a master here, and it needs to go to a slave here, and this is on the AXI, and let's say this is on the AHB, right? So here we need some conversion, right? So we are going to see for many of the signals how this conversion happens. So here we have taken the AW length and burst. So in case of the HB protocol, we just have the HBURST, which kind of has this information combined together. The length information and the burst information is combined in the HBURST. So let us see what is the glue logic which is required to convert the information which is coming through the AXI protocol to the HB protocol. So the key difference, let us see, between AXI and HB. The burst length happens to be actually AW length plus 1. So it can go from 1 to 256 beats. The burst length is explicit signal here. But here the burst length is encoded within the HBurst itself, and we don't have it as a separate signal. And only we have fixed burst types here, and also the number of beats is also fixed as per the encoding. And maximum it can go only up to 16 beats compared to 256 beats. So yeah, we see that we cannot go beyond 16 beats. So in that case, the transaction needs to be split into multiple transactions in case the length actually exceeds 16 beats. So AXI burst cannot be passed one to one to HP in general. So let us just look at the HP burst encoding. 0 is for single, 1 is for incremental undefined length, 2 is for wrap 4, and 3 is for incremental 4, and so on. The core translation idea is AXI gives the exact length, HB supports only limited shapes. So the glue logic must decode the EW length plus 1, decide if it maps cleanly, otherwise we have to split the burst. So if there is a one-to-one mapping possible, we will be able to give it directly. In other cases, we need to see if we need to split the burst or do any other glue logic for the same. So first thing is we have to calculate the beats. So based on the EW length, we calculate the number of beats, and then we choose the exact HP burst type it gets mapped to. So when it is one, it is a single transfer. 2 to 3, it goes for like incremental, undefined, and 4 is an incremental 4. 8 is incremental 8. 16 is incremental 16. In all other cases, it will be an incremental of undefined length. So IN0 is used whenever the exact length isn't presentable, whenever it is not 16, 8 or 4. In these cases, we'll go for the INs here. Handling wrap burst, so no, it must be a power of 2. Length is not 2 for 8 or 16. So wrap 4 and wrap 8, wrap 16, these are mapped easily. No others we need to split or downgrade to INs here only. So splitting long AXI bus. So in case of AXI, let us say the AW length is equal to 31, which is 32 bits. So glue logic will be to issue two AHB in incremental 16 burst, because the maximum AHB supports is still 16 bits. So we'll have to go for two transactions with the INCR 16. So or incremental burst with internal counter, or yeah, this will be a better way, or we can go for an INCR with multiple transactions with multiple bursts. So yeah, AXI burst, HB burst of 1, 16 beats in HB burst um, to 16 beats. So this totally will be able to get the 32 beats here. And state kept in glue logic. So the AXI bridge and AXI to HB bridge must have these kind of information like ID, the remaining beats, the current address, burst type, and size. So yeah, the remaining beats is nothing but the AW length plus 1 is the amount, and we kind of decrement for the HB master. So we'll just have a small pseudocode to understand like what exactly happened. So if the beats is going to greater than or equal to 16, in that case we kind of give the make use of the INCR 16. In case it's 8, INCR 8, and when it's 4, it's 4, INCR 4. In all other cases, we make use of the INCR. And in case we have something greater than 16, we kind of give it as two transactions, right? We kind of give it as two bursts. So why H plus equal to INCR is equal to simplifies the bridge, avoids illegal combination. HB slaves often ignore burst length anything. So yeah, this is like just to simplify, we can have it as H plus equal to INCR. But a better way to have is this kind of a logic, right? Which kind of directly maps the exact scenarios here. So AXI has explicit long burst, but HV has short encoded bursts. So the bridge must either downgrade or split the AXI burst to fit the HB burst model. So this kind of would have given a good idea about how to do the glue logic for the when we're actually taking the signal of length and the burst from the AXI world to the HB world. Thank you.